Hi, question number 1. Need a quantity that indicate the how fast capacitor charging and discharging. So the charging and discharging, how fast you can refer to the time constant tau. So the time constant tau for the, let's say, the charging process, that you can find the time taken for the 63% of charge Q from the Q naught, mean the time taken for the charging capacitor, the fully charged is Q naught. So at the time or the time constant T, you can find the 60% before the capacitor fully charged Q naught. Or you can use for the refer to the discharging process, let's say the 37% of the Q naught, meaning the charge flow up from the capacitor from the process discharging process, that you have 30%, 37% from the maximum Q naught, right? Number 2, explain why inserted dielectric material in the capacitor increase its capacitance. Let's say you have a 2-plate capacitor. This is a positive plate, sorry, and this is a negative plate, and insert the dielectric material between the 2 plates here, right? And dielectric material still have a positive and negative charge, and because this is negative, so negative, so meaning the charge is moving to the polarized to the positive charge, and this is positive, this is to the negative plate, right? So when you insert dielectric material between the 2 plates, the charge on the capacitor reduce, meaning the charge can store to the or increase to the plate capacitor when you insert dielectric material between the 2 plates, meaning the Q increase. Then you know the Q is a C times V, meaning if you increase the value of the C, Q, and the C is always increase. So meaning you can increase the capacitance of the capacitor if you insert dielectric material between the 2 plates. And the next number B, figure show the arrangement capacitor. Equivalent capacitance of the circuit is 0.5. Calculate the value of capacitance C. So what is the capacitance of capacitance C? So first, you can see here is a C, and this is C1, and this is C2, and this is C3. So first you combine the capacitor C and the C1. C and capacitor 1. This is a C parallel. So the total capacitor is C plus C1 is a 0.6 microfarad. And the second, you have a C2 and C3. And C2 and C3 also in parallel, so meaning you just put in the value 0.2 microfarad plus and 0.8 microfarad. So meaning this is equal to 1 microfarad. Okay, so if you combine the 2 capacitor here, you have 2 capacitor. This is a combination C and capacitor 1 or C1, and this is combination C2 and C3. And the C12 and sorry, this is CC1, and this is C23, and this is series. So meaning the total capacitance here, or effective capacitance, for 2 capacitor here is 1 over C1t is equal to CC1 is equal to 1 over C plus 0.6 microfarad plus and C23 is equal 1 microfarad. So now CT is given by the question is 1 over this one. CT is 0.5 microfarad. You can use the equation here to find the value of the C, and the final answer for the C is equal to 4 exponent minus 7 farad. Thank you.